Great to see you here in another video related to quality management. And here we're going to look at the interpretation of control charts. When we create a control chart, it's very important to understand what that chart is telling us. So let's have a look how we can look at the control charts. Now, when we have control charts, the way to interpret them is basically the same for all control charts. So when we look at the control chart, when we want to create a control chart, we have to take regular samples of the production. And we have to calculate the main parameter. Let's say we are in a production where we are filling bags with flour, 1 kilogram bags, and we want to be sure that the bags are filled properly. So we take a number of bags, we weigh them, we verify if the quantity is there. So we call that basically a sample. Or we can have a bottle of water or wine or beer, and we can verify if the content is correct. So each time we take a sample, and we're going to see what's happening with those samples over time. Now, on the samples, when we start making a sample, and when we have a number of parameters, it depends on the different systems of the control charts, we can create what we call an upper and a lower control limit. We can also identify the average, and the average should basically be the parameter that we want to have. If we want to have 1 kilogram of flour in a flour bag, well, the average should be 1 kilogram. So basically that's one parameter, but we also want to reduce the number of variations, and we have to be within acceptable variations, and we have to have a process that can provide those values. So basically we are going to measure the averages. We're looking at the variation, the variance, the standard deviation, and we can create what we call an upper and a lower control limit, where we are going to identify how our process is doing, and we will try to see what is happening with the process. Based on this, we can see how stable the process is, and we can identify if it is necessary to correct the process. Now, the old way of doing operations was that you never stop the process. Now, that changed because when a process is not working properly, you're basically producing goods which are not compliant with the quality standards. They may be unusable, they may be, let's say, costing a lot of money because you put too much product in it. All kinds of things may go wrong. And when something goes wrong, we have to stop it. And the statistical process control, the control charts, will provide us with information of how the process is going. And once we know that there is a problem with the process, we can stop the process and approve it or improve it, repair if it's necessary. When we look at the control charts, the control chart looks a little bit like this. For a process which is in control, we have in fact sample averages which are around the population average. So the dotted line is the average, and the upper control limit is the upper line. If our sample is above, there is something wrong. When it's below the lower control limit, then there is also something wrong. So basically, when we have this control chart, we can say this is a process in control. Now, we can have a look also when something goes wrong, we can have some assignable causes here. So there are typically 5 above or below, in a run, a sudden change, and out of specs, out of specifications, and we have to do something about that. But let's have a look at those in detail so you can clearly understand what is happening. This is the process in control. You see that the different samples, the averages of the samples are spread around the average. They're quite okay. They're far away from the upper and the lower control limit, which make us conclude that this process is basically working well. There is no problem that we can identify here. So we keep it running, and we just follow it up and see what's happening. The possibility here is when we have 5 or 7 above or below average. Now, when we have 5 or 7 below average, it means that there is something with the setting of the machine. Sometimes we refer to 5 or to 7, it depends on the book that you open, but basically it means something changed with the setting. And it means that there is a cause for this variation. So there is something wrong and we have to stop the production, we have to verify what went wrong, and we have to remediate it. Continue working like this will not be acceptable anymore. So we have to see what is wrong, what is the reason, and we have to repair if it's necessary. A process in a run, so what we see here, we have an upward tendency. From a certain moment, we see that the averages are going up, which basically means that there is something going wrong with the process. And also here, this is an indication of a problem. We have to stop the process, we have to verify what's happening, and we have to adjust it. The faster we adjust the problem, the faster that we will have a, let's say, high quality production again. Another element is a sudden change. So something went wrong here. What can it be? What was the reason? Did somebody see something? Did they repair it afterwards? Was it a different operator at that moment? Did we change the procedure? Anyway, we see that there is a break in the tendency of the other points, so there is clearly something wrong. The last element that we can have is that the process is out of control. This relates to the fact that the average, the sample average that we are evaluating or that we found at that moment is outside of the control limits. In this case, it's outside, it's above the upper control limit, but it also could be below the lower control limit. Those are two elements that we have to avoid, and we have to be very careful with those. So basically, when we see the out of control warning here, we have to stop the process and find out what is wrong. So basically, these are the elements I wanted to show you how those processes work, how we can interpret the statistic process control, and we will continue with this with different types of control charts. We will be looking at X and R control charts. First, we will start with the control charts with the known standard deviation, and then we will continue with the control charts with an unknown standard deviation. You're doing a great job, and I'm looking forward to seeing you in the next video. Thank you, and bye-bye.